Science first, safety second.
Oh look, it's a pile of rocks.
Wow.
We're down here at the beach to collect our sand.
My dad doesn't want to buy a sand.
For the first ingredient of our science experiment. Let's get it poppin'. All right, Ivy, would you like to explain to us what you're doing right now?
Right now we are measuring the amount of sugar and baking soda that we need for our fire snake mixture. It has to be 4-to-1. So.
Right on, my dude.
Let's go burn some sugar. Yum.
So currently we have all our materials and our gloves. It's gonna be lit, literally.
All right, guys, we're out here back at it again.
Locked out.
Damn, every time. We're locked out of the house again, but that's okay. We can use our super scientific MacGyver skills to get back in, get what we need, and get it poppin'.
Yum.
Hello. Okay, good talk. The sand seems to be a bit moist for our liking, so we're gonna let it dry out for a little bit. All right, guys, we got our protection, because you know what they say. First is science, second is safety. When we can knock both those out of the way, let's do it.
One eternity later.
Oh, starting to caramelize. Creme brulee, my friend.
So cool. It looks like when you squeeze like a pimple or something, doesn't it?
Would you like to go squeeze it, Ivy? We've hit a dry patch.
Can I pour more on? I won't catch myself on fire, I promise.
Don't lean over with your hair and stuff.
Famous last words. I won't catch myself on fire. I promise. Oh my god! Dude.
What?
That was so hazardous. I was sitting right.
That's when you catch yourself on fire.
Guys, that's what I call science first, safety second.
Okay, it's working now.
Is it?
You need to think about that. This is flammable, and you poured a constant stream of it onto flame.
Sorry.
Which meant the whole stream caught on fire.
Sorry.
So now you understood, I hope, why you don't pour things onto open flames.
Yeah.
You wouldn't do that with a grill. You wouldn't do that here. Now you know.
It's
Sorry.
a dud.
Okay, so overall, I give this a 0. Should we splat? Can we spray it with rubbing alcohol?
That's a great other lesson where you end up burning your eyebrows off.
Dang.
I don't have any, so it's all good. Just had a near-death experience. And so our solution is, why not light more stuff on fire? Alright guys, so unfortunately that was a bit of a dud. Give it a nice gentle brush, just to see what's going on here.
It's shiny.
Oh! What do we have here? As you can see, there's still a lot of sugar in the center that did not get its chance to burn. Edible, question mark?
Don't. Period. Try again.
Smells like
On a smaller
s'mores,
scale.
so it must taste good. All right, guys. So that was a bit of a letdown, bit of a dud. There's no way to truly pinpoint what was wrong with our experiment, but at least we've got ourselves a nice batch of natural sand. And with that, we're out. All right, guys. Science first, safety second.
There are 3 main reactions that happen when we make this fire snake. The first of these reactions occurs when the sugar combusts or burns and actually reaches the fire in the presence of the oxygen. So this produces carbon dioxide and water vapor, also a gas, that pushes more of the sugar and baking soda mixture up. This is like the helium of the balloon, as you could say. Some of this additional sugar that heats up but doesn't reach the oxygen, so instead of burning, it undergoes thermal decomposition, producing solid carbon and more water vapor. This is like the outer shell of the snake that gives its like form. Now lastly, the baking soda also decomposes in the heat because it doesn't reach the oxygen, producing solid sodium carbonate and carbon dioxide and water vapor. Altogether, these 3 reactions produce the solid components of the snake, the inflation, and the black color. We also learned
that it's not the best decision to put flammable liquids over open flames, as you noticed in our video.
I got a huge burn on my arm.
That is, unless you're doing science first, safety second. There. Bet.
Thanks so much.
That's a wrap. We out.
Is it off yet?